Today we're going to make the ultimate 3D printer enclosure. I bought my first 3D printer, a Creality CR6 SE, about a year ago. I did a lot of research on what people did that worked and did not work when they were printing, different features that came with the printers, what kind of filament to use for functional parts versus just cosmetic items. There's a ton of stuff to learn when you're just getting started with 3D printing. I knew of a few projects I wanted to make right off the bat, but I knew there'd be more in the long run. So like any project that I make, I start off figuring out what features I want, and then I start the design process. And in the case of this enclosure, there's a lot of them. First off is the enclosure itself. There's a lot of different benefits to having an enclosure, like keeping the dust off your prints, giving it a controlled temperature to help reduce warping. And on certain filaments like ABS or nylon, it helps you control the fumes that it puts off when you print with those. But I also wanted to be able to open it up so when I'm printing with things like PLA, it doesn't get too hot in there. Second would be a place to store the filament itself. I wanted a large variety of color and different types to be able to print different parts. With this, I needed this to be airtight because some filaments will absorb moisture, so I had to have a way to keep that out of there. Third, I wanted to be able to change the filament out quickly. I didn't want to have a bar running through the center of all these rolls because if one in the middle ran out, I'd have to take it all out, pull them all off the end to get to the one that ran out. One, that takes a lot of time, but two, that's going to allow a lot more air and humidity back into that chamber, which could do some damage to the filament that's already in there. Fourth is going to be storage. I knew the drawer that came with it was not going to be large enough. I needed a place to also keep cleaning supplies, glue sticks, and a trash can for failed prints that I could throw that kind of stuff away. 5 is control. I'm going to have a Raspberry Pi that is running Octoprint, which will allow me to upload files from my computer upstairs directly to the printer and start them if I want to. I can monitor things like temperature, humidity, and I'll even have a fire sensor on there, so if something is horribly wrong, I'll be able to catch it the moment it happens, even if I'm not in the room. 6th is a webcam. I already mentioned that I wanted to be able to monitor this remotely, but I also wanted to be able to make time-lapse videos so I could include them in my normal build videos, but that way you could see the part being printed and see how it plays out into the larger project. 7 is ventilation. I haven't fully figured out how I'm going to do this or even where it's going to go. It's going to be close to a window or a place that I could put another hole in the wall that my wife would love, I'm sure. But however I do it, I need to make sure that the temperature inside stays consistent. I can't be pumping a bunch of hot air outside and then replacing it with cold air, or it defeats the purpose of the enclosure altogether. 8 was lighting. This is a pretty obvious one, but I wanted to make sure that the top and the main chamber were very well lit. Not only just for appearance, but also to make the videos look better when I record them. 9th is going to be relocating the power supply outside of the main chamber. Because so much heat can build up inside, and some from the power supply itself, it's not good to have that in that kind of environment. So I want to make sure that that stays as cool as possible. And 10 was to have a filament cleaner. I knew that when that door opened up, dust was going to settle in at times. I wanted to make sure that as I'm pulling filament down through the top into the printer, there's no dust or any other dirt on the filament itself that would mess up a print. And with that, if it's built into the top of the chamber, it should help prevent air and heat getting back up into the filament chamber. I decided to use 1/2-inch MDF for this project for a few different reasons. First, I had a bunch of it already on hand that I needed to get used up. Secondly, it paints really well with no weird edges, which is nice. And third, I was hoping that it would absorb some of the vibrations when the printer's actually printing to help with print accuracy and just noise levels. Now, I understand this printer gets very hot, and some might consider this a fire hazard, and I could have used a different material like plywood or cement board, and that might be accurate. But because I don't leave the house when this is going, and I have things in place to monitor it, it wasn't really a concern for me. The other thing is I'm not actively heating this. I'm just using the normal heat that the printer itself produces. If I actually had a heater in there making it even hotter inside, it may have been a different story. Because that's not the case, I'm fine with the MDF. I've had this enclosure for almost a year now, and there's a lot of things I really love about it, but there are a few things that I don't care for. Make sure to watch to the very end, and I'll go over the 5 things I would change if I was doing this process all over again. If you're new here to the channel, please consider liking, subscribing, and hitting that bell. It really helps the channel out as we move forward. There are a lot of thoughts and learnings I want to share with you all, so let's get started by ripping all these boards down to size. Once all these panels were assembled and painted, I noticed you could see the unfinished side in the slot through the plexiglass. To fix that, I used some black silicone caulking to make sure that that was all covered up. You couldn't see anything afterwards, which was perfect. It also made sure that the actual panes didn't shift inside the panels. For the LEDs, I used one long LED strip. This was one, more cost effective. Two, it made sure that the colors were the same, both top and bottom. And three, I was gonna have to drill a hole anyway for the humidity sensor for the top. So regardless, there was gonna be a hole drilled into it. So I just filled it with caulking later on and we were good to go. This seal will help keep air and moisture out of the filament chamber. I wish I would have found a better solution prior to this so you wouldn't be able to see the seal from the outside, but it's a very minor thing in the long run. Now, even though that compartment's going to be sealed, moisture will still get inside. To combat that, we're going to have 4 bins of silica gel that will go underneath the filament to help remove any moisture that does get inside that chamber. The really cool thing about this silica gel is that it's actually reusable. I can take these out, which is why they're in little oven pans, and I can put them in the oven for an hour or two at low heat, and it'll actually absorb the moisture back out of these beads. When they are good to go, they are an orange color. Once they absorb a bunch of moisture, they turn green. So it's really easy from a visual standpoint to know when it's time to take them up there and recharge them. I had to suspend the filament over the silica beads, so I printed off a bunch of these pieces, ran some threaded rod through it, and this is so nice because now I can just pull out one roll at a time whenever I need to, and not all of them at once. These sponges will help clean the filament as it goes through into the main chamber, but also help keep heat and air from coming back up into this chamber. As far as the screen on the Raspberry Pi, I made a frame for the outside of the enclosure just to clean up the look a little bit. To the back of this, both the LCD and the Raspberry Pi will mount to that directly, and everything will hook up there. I spent an hour covering all the things Octoprint allows you to do with all the different plugins and add-ons that it has. It's really amazing. Because of how tall the cabinet was, I attached these to keep the door only opening halfway. This made it easier for me to reach to close the door and to make sure it didn't actually hit the ceiling if it opened all the way. Now this printer by default uses a Bowden tube setup. Now the downside to this is that it actually feeds in from the side, and since all my filament is up above, I wanted a better way to do that. I mounted the power supply underneath the main chamber above the drawer. That's where the on-off switch is, which is kind of a pain to get to, but I know where it's at, so it's not that big of a deal. The The other nice thing is that there is no back on here, so all the heat can escape anywhere it needs to. That's not a concern anymore. It also is able to plug into a battery backup below, which allows me to make sure that if there is a power outage or just a surge in my house, I'm not going to fail a print just because of that. I decided to go with a fan and filter method as far as getting rid of the fumes from the prints. I didn't design this. I found someone on YouTube that did, and it actually took his exact print, and it worked awesome. But the thought process behind it is that you actually have a blower style fan mounted inside your chamber and an actual adapter that goes onto that, which allows you to snap on a respirator filter that is made for plastics, formaldehyde, a bunch of vapors, gases, that kind of stuff that will help eliminate a lot of that. Now, I haven't tested it afterwards. I don't know what percentage actually filters out or how well a job it does. What I can tell you is that if I had this turned off, and I have forgotten once to do so, and printed like ABS or nylon, it smelled really, really bad. And I got a headache within a few minutes afterwards. Every time that I've opened it up right after a print with that running, I smelled nothing and no headaches. So I know it's doing something, I just don't really know how much. The one downside of having this many filaments is that if you have different resistance between different spools, you could get inconsistent prints. So because all filaments come to this centralized hub, they're all going to have similar resistances. So when I go to calibrate the E steps of the printer, they should all be fairly close. I decided to add this LED strip to the top of the printer. When I was capturing the time-lapse videos, it was still very, very dark with just the normal LEDs that I had in here. So I added this LED strip. This is mounted to the bottom of the filament hub, actually. The line then runs down the side of the main support and goes into where the old power switch used to be, which is now replaced by two power switches, one for the LED and one for the fan and filter up above. For the webcam, I wanted to make sure that it was out of the way, but also in a good position to capture those time-lapse videos I wanted. By mounting it to the main support pole, I can run the wire all the way up it over to the Raspberry Pi, and it's still in a perfect position. So now comes to everyone's favorite time. What would I do differently after using this thing for a year? And the first one of those is I would have used plywood or cement board instead of MDF. Partially because plywood would be a lot stronger than MDF and weigh a lot less. I have noticed in some areas where it has bowed a little bit, not that big of a deal, but because it's going in a basement, there's a chance that it could suck in moisture and expand and distort a little bit that way too. Second is not making it quite as tall. Transparently, even though I had all the measurements and all the cut lists and everything else, until I actually built it for some reason, I didn't realize how tall it was actually going to be comparatively to the room. And because when designing it, I wanted to cram every feature that I possibly could think of in there. It ended up being very, very tall. Now, this wasn't the biggest issue. I can still fit it downstairs. The door still opens just fine, no big deal. However, when I have to access some of the filament that's in the very back of the top chamber, it is kind of hard for me to reach, and I'm 6 foot. So I can imagine for others, it'd be even harder. And there are times when I'm working on it, actually bust out a step stool just to get to the very back. Third, I would have found a better way to seal off some of the filament inside the main chamber. Whether that was not letting it poke out the end and just kind of dead ending into the edge of the filament hub, that could be an option. But I have found a couple times where if I don't use a filament for a long period of time, that filament will actually break off at the top of this tube. Good news is I know that not much moisture or air is getting up into the main chamber, or else it would break off and become brittle up there. However, it's still getting up through the tube, and that's a long piece of wasted filament in the long run. Or I would have used regular bearings. I decided to use these V-groove ones because I had a bunch of them laying around from the litter box enclosure, and I wanted to use them up, and I thought it'd be a great idea because it would help kind of self-center the actual filament spools and not have them, fall off the side or become out of alignment. Sounded great in theory, but in reality, it actually created more friction than a normal bearing would have. So since then, I actually went back and reprinted all the plastic pieces and used all normal, just basic bearings, and I get a lot less resistance. And since I've replaced those, I get much more consistent results from roll to roll. And lastly, I would redesign these little Mario-looking pipes. They work great in theory. Once it's installed, they're all good to go. The biggest problem is if you're starting a new roll of filament and you're sticking the end of the filament down through, rather than it just going through the sponge that already has a hole right in the middle of it, it tends to just smash it down. So actually you have to take the top off of this, take the sponge out, put it on the filament, then feed it down through, and then seal it back up. And then it's good to go for the whole roll. But when you're working on the filaments that are in the back part of the chamber, that can kind of be a pain in the butt to get back there and actually do this whole process. So that's going to do it for this one. Overall, I'm very happy how it turned out. Most of the stuff I don't like are very, very minor gripes. Not that big of a deal. But I love that it gives me so much flexibility to adding different types of material to print with, being able to modify the printer, having plenty of room down there for expansion. It's just been very nice to work with. I will have plans on the website eventually over the next couple of weeks for this if you want to make one yourself. If you're thinking about getting into 3D printing, but you're not sure if you can figure it out, my advice is just do it. There's just so much you can do with this. It's so much fun just tinkering and designing things. Or if you don't want to design it, you can just go to sites that already people that have designed a ton of stuff for free that you can download and just print on your own. There are a ton of videos to help you get through the setup process, calibrating it, the do's, the don'ts, all those things. The community in 3D printing is absolutely amazing. You get a ton of different resources you can go to ask questions, get advice. If you have issues with your prints, they can help you, tell you, check this may be off. It's been an awesome community to learn from. 3D printing is so much more than just printing off trinkety things or cosmetic items. There are so many parts and different things you can do with it that's unbelievable. And yes, it can be tedious to learn. And in my own experience, most of those issues were self-inflicted from modifying the printer so much. Once it's set up correctly, it's well worth it. For me, I really love the design process. I like being able to make something exactly, precisely how I want it. That gives me energy. But I also love that I can either be out in the shop working on something else, and it's like a second set of hands making a piece for me in the basement. It also makes me feel less guilty when I'm just sitting around the house for a little bit or watching a football game. I still feel productive because something is still being created, which is kind of cool. Let me know in the comment section below if you have a 3D printer and you've used it for any kind of woodworking or shop-based project, something you made for that, whether it's a part, whether it's a tool, whether it's a replica of another more expensive tool that you made at a much cheaper cost. Let me know about that in the comments. I'd be curious to see what you guys all do with that kind of stuff. Overall, I hope you enjoyed the video. If you're new here, be sure to like, subscribe, hit the bell for me. I greatly appreciate that. If you want to help support the channel, there'll be a link to my Patreon at the end of it. To those that are already supporting me, thank you as always. And to my gold members, special call out. Thank you again. As always, really, really appreciate that. And as always, thank you so much for watching. We'll see you next time.